Welcome to clickmyproject.com. Let we discuss about the process blind image steg analysis of JPEG images using feature extraction through the process of dilation. Let me see the abstract of the process. The identification of input images into original or stego based on the features extracted from the images has numerous applications. The input images may contain any secret information in them. For the identification of the original and the stego images, extraction of the features from the images were done based on the three domains of the images like spatial domain, spectral domain. DCT and DWT were employed for the conversion of the input images from the spatial and the spectral domain correspondingly. The DCT transforms the images to frequency domains. A discrete cosine transform expresses a finite sequence of data points in terms of sum of cosine functions oscillating at different frequencies. The cosine transformation splits the image into high and low coefficients. The information in the high coefficients is not up to the visual perception of the human eyes. The required informations were present in the low coefficient contents of the image. The wavelet transformations converts the images into four coefficients like low low, low high, high low and high high. The low low coefficients contains the pixel information while the other coefficients contains the spectra informations. The statistical parameters like mean, standard deviation, energy, entropy, correlation coefficients and histogram were calculated from the signals, and the extracted values were used as features. The extracted features were then classified using SVM and neural network classifier. The classification process in SVM is based on kernel functions which were identified for the classes which were identified for the identification of the classes in the images. The neural network identifies the categories based on the generated weightages for the neurons that are generated in the layers of the network. The classification performances were measured in terms of the classification performances like accuracy, sensitivity, specificity and confusion matrix. Let me see the flow of the process. The input image is obtained. It may be normal or stego image. The image is divided into some blocks. Here we are dividing the images into 8 cross 8 blocks. For each blocks, DCT is obtained, DWT is obtained and the original blocks were used as it is. The DWT coefficients low 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 high high low and high high were taken. The blocks were directly used for the extraction of the features. The splitted blocks from the splitted blocks mean, standard deviation, skewness, kurtosis, correlation, covariance, energy, entropy, they were all measured. Similarly, for the DCT coefficient of the block, the parameters were calculated, and also for the DWT coefficients, the parameters were calculated. So the calculated values were used as the feature values for the classification processes. This statistical parameters were unique for every images, and they were helpful in the identification of the modifications in the images. Since the modifications in the images will not be visually clearer, the statistical parameters were helpful in the differentiation of the original and the stego images. Then the extracted features were given to the neural network and the SVM classification methodologies. The input features, the input image features were extracted by the same process. Similarly, the training process is employed for some set of stego and original images. The stego and the original images that were used in the training processes, the training process, the some features were extracted for all the different types of original and the modified input images, and the images were classified as original or stego. Finally, the performance of the process is measured with the help of accuracy, sensitivity, specificity, and the confusion matrix obtained. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. Here we select any one of the images present in the dataset. So the images were selected and they were displayed. After that, the displayed image is divided into 8x8 small images, and for each images DCT and DWT were calculated. The DCT and DWT calculation were used for the identification of features from the input images. The extracted features were then used for the classification of the input signals using the SVM and neural network classification methodologies. So this is the input image. So the input image, the features were extracted from the input image, and the extracted features were based on the statistical parameters like mean, standard deviation, skewness, kurtosis, entropy, like that. After that, the the extracted features were passed into the classifier. The classifier SVM and neural network were used. The SVM classifier classifies the images, and also the neural network classifier classifies the images. So this is the SVM classification result, and this is the neural network classification processes. So the neural network training tool is implemented, and based on that this classification is employed. Overall, the accuracy of the processes were displayed in terms of the confusion matrices. So this is the confusion matrix for the SVM classification. This is the confusion matrix for the neural network classification methodologies. So thus we have classified the input images into stego or original based on the statistical features extracted from the images, and the performances of the processes were analyzed with the help of the confusion matrices. Thank you.